we really hope that the sessions today will be productive. And I look forward to meeting some of you during the break and during the sessions. So thank you very much for the introduction, Guru. The team that I lead at Google is really focused on creating abundant access. As you know, around the world, there's a tremendous shortfall in access to the internet. There are many countries where only a small percentage of the population is online. And even in developed markets, in spite of the tremendous investment and innovation that's happening in the industry, we're still short of where we need to be in terms of growth in capacity. There's a significant shift to wireless, and deployment of wireless infrastructure is still very capital intensive and very expensive. So we're looking at technologies and business models that can allow access to the internet to be scaled faster. And clearly we think that's very important to the future of the internet. There's tremendous growth in data center capacity. There's tremendous growth in content and services that people want to use anywhere, anytime. Cisco VNI reports show CAGR annual growth rate of internet traffic is 35% or so, with no signs that it's slowing down. A lot of that is the growth in mobile video, but even that is going in transitions to HD to even 4K. So we're seeing even per stream, data needs are growing rapidly. And so this is a challenging problem. And worldwide, I think there's in excess of $300 billion per year spent in CapEx, many by the companies present here. And even that is not necessarily going to keep up. So I think innovation in technologies, essentially taking Moore's law and using that to scale the economics of networks, is kind of one of the exciting things we find about CORD. So these software-based technologies taking more generic white box hardware that can be scaled faster, we think is really what the future will bring. And so I just wanted to mention a little bit about what Google has done over the years to provide a growing set of services and capacity. And this is actually not my area at Google, but I want a shout out to the teams that develop the infrastructure that all of the Google services run on, and now is being made available to the whole community through the Google Cloud platform. And over the last several years, Google has increasingly attended technical conferences and published papers giving really deep insights into a number of the technologies that have been developed and scaled at Google. And we've been in this way, in addition to open sourcing some of our platforms too, to try to create greater awareness and momentum in the industry. Obviously, Google is well known for the consumer services that it provides. Those are powered by data centers, which have involved tremendous levels of innovation around scaling compute, storage, and networking, and also looking at energy efficiency, and of course, in addition to economic efficiency. But those data centers rely heavily upon network performance. And some of the technologies which have been discussed publicly by Google in various industry forums include maglev, which is a load balancing front end through which all Google traffic flows. Jupyter is a cluster fabric, which was, I think, discussed in detail about a year ago at a conference. Amin Vedat presented some details of the Jupyter fabric. So this is used within a data center. And the bisection bandwidth of Jupyter can scale to a petabit per second. So think of that as, I mean, that's 100,000 endpoints, each getting 10 gigabits per second. So this is just tremendous capacity and scale. Andromeda is network virtualization, which is visible to the whole community through Google Cloud Platform, and of course is used internally. And B4 is our long-haul WAN networking technology. All of these technologies are based on SDN principles, which were really embraced broadly by Google over the last 8 to 10 years. And so B4 is the wide area network that relies on long-haul fiber optics for basically doing data center to data center communications and also providing services really to people throughout the world. So in addition to the focus on SDN and virtualization and the cloud, Google is also making big investments in the physical layer infrastructure. You still have to carry the bits on physical media. And so one example of a recent project that Google is involved in is the faster optical network, where Google partnered with several other major telcos to invest in a very high capacity submarine fiber infrastructure, which runs from North America to Asia. We partnered with China Mobile, China Telecom, Singtel, and additional carriers in Japan as well. And this infrastructure provides 60 terabits per second of capacity, and each of the carriers, Google has access to 10 terabits of capacity there. And it's pretty remarkable technology. So this is 100 gigabits per second per wavelength, 100 wavelengths per fiber. And so just in really massive capacity. And that was first lit up just a few weeks ago and is just starting to enter commercial service. So we're very excited about the progress we're making, working with partners and delivering better services and using the technologies that CORD is focused on to really make those services much more flexible and much more scalable and to improve the economics as well. As Guru said, CORD has a focus on residential, mobile, and enterprise segments. And this is actually very much the same areas that my area at Google is focused on. So in the residential area, I'll talk about a couple of projects we have in each of these areas. And while I can't claim that we have universally deployed these technologies at the edge, at the access edge of these networks, we've definitely used elements of SDN and virtualization and pushed a lot of the control plane and services into the cloud in a way that's made these services much easier to deploy and scale. We've also learned a lot about the challenges of doing this well and starting to do it at scale. Through the CORD partnership, we're obviously very excited about trying to share these experiences with the community. Obviously, there are significant benefits of SDN and virtualization, so scalability, agility. Obviously, the economics and performance can scale closer to the underlying Moore's law trends that drive the silicon cost structure, as opposed to having proprietary hardware that tends to refresh and change much more slowly. But on the other hand, it's not all easy. There are challenges around how do you model and actually understand the network at scale, configuration, and failure handling and monitoring, and even the operational processes of managing these networks are all challenges that companies and people actually operating and deploying these networks have to understand. And so these are some of the experiences that us and many of the other major carriers and large ISPs have experienced. And I think being able to share those experiences and so on, I think is very helpful for the whole community. So that's definitely an interest of ours. So let me talk about a couple of the projects that we have in each of these areas. And this is just simply an example of some of the things we're doing and how these might be relevant to the CORD mission. So one of the projects that I certainly know well is a project called Google Fiber, where we're deploying residential and small business fiber to the home service. So we're trying to offer order of magnitude gigabit per second symmetric rates for home users. And we've started to deploy these networks in a number of cities where we're building in about, we have live customers in about 5 cities, and we're building in an additional number of cities, just focus on the US. And we've done a number of things to architect this network that rely on these scalable cloud-based services. So things around authentication and provisioning, for example, cloud-based radio servers, simply replacing what would be proprietary hardware with software that can easily scale and provide redundancy in a cloud infrastructure. So authentication and so on is something that we've made cloud-based. Additionally, the TV service that we offer, as a broadband service provider, you typically have to offer TV content. And we have a content delivery network, which is based on the YouTube video pipeline, but is fully IP-based. So we ingest all of the usual wide area feeds for content that we license from the content owners. So Disney and ESPN and the major networks and so on. And all of the security, decryption of that traffic, the transcoding, and the distribution of the traffic is based on virtualization and SDN technologies. It's all based on multicast IP down near layer 2, and end-to-end, even though it looks like linear TV, it looks like a traditional service where you're changing channels and picking out content, it's all IP-based. So for the point of view of our network, there's really no difference between over-the-top video services, on-demand video services, and traditional TV. It's all just an IP video stream. And the technologies that we're talking about today basically rely on basically the foundation of these services. And another service that we have is a traditional VoIP-based telephony service. So to the user, it looks like traditional fixed-line telephony. Sounds very old-fashioned, but the whole infrastructure is voice-based. So all of the data and control plane is cloud-based, and that means it's completely agnostic to the type of client that you plug in. So it could be a mobile phone app, it could be a VoIP termination that allows you to plug in a POTS phone, or it could be a browser or a notebook or a tablet. And that gives us a great deal of flexibility in how we actually roll out and provision that service. So these are some of the things we're doing. I should say, though, that we haven't yet done things that we want to do, such as our BNGs aren't virtualized. We're using somewhat more traditional approaches in portions of our network. And I think we're very excited to be brainstorming with our colleagues in the industry about how these FTTH networks will evolve and how more of these technologies can be used broadly. So focusing on partnerships here is actually very important to us. And we're actually starting to have some discussions with carriers about technologies that we use and potentially we can collaborate with carriers on. In the mobile area, one of the most visible initiatives we have going on, and this is actually a different area from mine, but this is the Loon project. And the goal here is to provide access to mobile services, LTE in this case, by using base stations, ENBs, that are actually carried on aerial platforms. So the goal here is to deliver services often in rural or remote areas where there's no connectivity by putting LTE ENBs on an aerial platform, in this case a balloon, which is floating at roughly 20,000 meters. So approximately twice the altitude of commercial aviation, so well above where air traffic is. And from that 20-kilometer altitude, the link budget to even unmodified handsets is actually adequate outdoors to provide good services and good throughputs. And so the Loon team, which is part of the X organization, is really doing a great job making progress here. And the business model is to partner with carriers in country. So it's simply view this as a virtual extension of their terrestrial network. So it uses, it essentially looks like a roaming network to the carrier that they're essentially wholesaling. And that allows them to expand the footprint substantially where the economics of a terrestrial network aren't adequate. And but this immediately creates a very exciting challenge, which is that this is a case where the infrastructure itself is dynamically moving, in some cases with a configuration that can change quite rapidly. So this is much more so than a fixed terrestrial network where it only changes in topology when there's a configuration change or when there's a failure. In this case, the network is always changing because the topology of the balloons is shifting in real time. So routing traffic through this network is a perfect problem for SDN approaches. And so we've been developing sort of an SDN-based mesh that allows you to optimally route traffic across the Loon network, where there are combinations of balloon-to-balloon links for backhaul and also balloon-to-gateway links. Every balloon serves user traffic, but it might or might not have a direct connection to a terrestrial gateway. And so our team's actually been working closely with the Loon team to try to sort of deploy these technologies. And there's another part where cloud-based technologies and sort of SDN technologies are coming to bear. And that's as we integrate this network of ultimately a large number of small ENBs into the carrier's packet core, which right out of the box isn't necessarily designed to have transient EMBs that might appear and disappear in the network. So we're developing a sort of a virtualized cloud-based shim that sits between the carrier's packet core and the ENBs downstream. So it can look like a more persistent, smaller number of network nodes, not to overburden the carrier's packet core. And of course, this is all based on SDN technologies, but using the 3GPP2 standardized interfaces upstream so that we can look like essentially a small shim that virtualizes the complexity that's actually present in the physical network. So a lot of the technologies, again, that CORD is working on, we think apply in an interesting way to mobile networks as well. And in the enterprise world, we're actually doing a bit less, but we're doing some, we're doing some Wi-Fi deployments. We have deployed Wi-Fi in many of the Starbucks in the US. There's nothing particularly dramatic about the network architecture there, since these are small little islands of coverage. But we are doing some more interesting deployments now in India. So there's a project with the Railway Authority in India to deploy free Wi-Fi in initially 100 and ultimately 400 to 500 of the biggest Indian railway stations. And these are large stations where literally millions of people aggregated across a number of stations flow through every day. And these are people that would love to download some content or check their email or even check the railway schedule while they're actually there. And so a large number of transient users. And we've had tremendous success with this project. And this is, of course, using a number of these technologies as to basically make authentication and ultimately to allow more seamless roaming of users among the nodes in the network at a station. So to make sure that IP addresses and session mobility can work over a relatively large area without having to re-authenticate, without having your IP address change. And so we're deploying cloud-based technology, once again, SDN-based, that essentially powers and enables this network. And we're also looking at how some of those technologies could help Wi-Fi deployments in small businesses and so on. A related effort, which actually is not specifically important to CORD, but it's another example of using technology to sort of unlock opportunities, sort of to democratize access. And that's the effort that we're doing in spectrum licensing. So all wireless systems depend upon having access to radio spectrum. In Wi-Fi's case, it's unlicensed, but the cellular technology we all depend upon uses licensed spectrum. And the rapid growth in demand for those services is causing a bit of a crunch in the availability of that spectrum. And this spectrum is incredibly expensive. The carriers spend billions of dollars on licensing the spectrum, and then they have to deploy networks, which also cost billions of dollars. And 5G services will require even more spectrum to be made available. And the economics also become a bit challenging. So we've been looking at clever ways of using software technology, cloud-based services, to unlock spectrum. So in some sense, while spectrum is considered scarce, the thing that's really scarce is using it efficiently. There's actually a lot of spectrum which is actually relatively idle. If you look especially at government use, measured over space, time, and frequency, this sort of five-dimensional space, it's actually very sparsely populated because some services require critical spectrum for maybe a defense service, but they only need it a very small amount of time. So why can't you use that spectrum opportunistically for private sector, commercial services, and you just agree to get out of the way when it's needed for a higher priority service? And that sounds hard, but of course with software running in the cloud, you can easily have a database that's simply a geodatabase that simply gives authorization and permission for devices to use radio spectrum, provided a high priority user doesn't need it at that time, place, and frequency. And so there's a particular effort around 3.5 gigahertz, the CBRS band, where the FCC is very close to finalizing rules that will unlock 150 megahertz of spectrum, which is primarily used for defense purposes and therefore has been kept vacant. And traditionally, all of those users would have to be cleared out of that spectrum for it to be made available to carriers. And that would take 10 or more years, and it would cost a huge amount of money because all of the defense equipment would have to be replaced or rebanded, which is a very difficult process. So we've worked with a number of partners, including Verizon and Qualcomm and others, to really create good progress around a more flexible scheme where if the defense users don't need it at a particular place and time, commercial users can use it too. And we think this is going to be very important to creating low-cost spectrum that has very good attributes, especially for small cell deployments, indoors and public spaces and so on, that can unlock more capacity. So while not directly related to SDN and NFV, it's another example of scalable software technologies reducing friction in the carrier market. And we're excited to be working with the industry on making this happen. So to summarize, in a sense, I mean, and I think you'll hear more about the details of this today, is that we've had a lot of experiences across Google around moving more and more services to the cloud and moving more of the logic of how networks behave from hardware to software. And doing those two things well allows you, as I said at the beginning, to reduce the friction between the underlying Moore's law trends, which drive the hardware costs, and the provisioning of services. And if you can reduce that friction, the overall economics of these networks can scale in economics, but also performance can scale in ways that are much more attractive. So we're very, very excited and really believe in this combination of SDN NFV technologies combined with cloud infrastructure. And of course, it's, yes, you get agility and scalability, but it's not without challenges as well. And as I mentioned at the beginning, just provisioning and configuring this network, monitoring this network, understanding how faults propagate in this network, and even the operational processes around managing networks like this are all different and all have new challenges. And I think industry forums like this can really be a good vehicle for comparing notes on sort of best practices in these areas, because you have to do all of those things well to kind of get all of the advantages. And I also want to mention that partnerships are actually very important to us. And so while in a couple of cases we're building some businesses that actually are providing some end user services, part of that is to really just understand the technologies and understand how they scale. Internationally, and also domestically, where even my group is increasingly working with carrier partners, because we really view that the scale of the problems we're trying to address are really large. No one of us has the technology and balance sheet scale to really solve a meaningful part of those problems. And so doing a lot of this together makes sense to us. And so we're very excited to be working in this forum with partners and working with partners really across the industry. So just to wrap up, I mean, Google's very excited to be joining CORD. We really believe in this principle. And of course, in general, Google has been a big supporter of open source approaches. One thing I should mention actually that we have done additionally, where we're collaborating already with a number of OEMs and carriers, is a project called Open Borders, where this is essentially a set of open sourced APIs for cellular base stations. And what we're trying to do is to provide more network visibility up through the application stack. At the moment, the layering of the network stack works very well for abstraction purposes, but especially in mobile networks, there's a lot of information available down near the physical layer that you lose. And one simple example is just networks tend to be pretty idle at 2 a.m. And so there's off-peak times where traffic could be shifted if you knew that the carrier wanted to have a policy to do that. So by having APIs that expose that information up through close to the application layer allows carriers to essentially encourage services, if they can, like app updates or refreshing some content and stuff that is not time critical, to shift to off-peak times. And that could even be exposed to the user, where even the user could potentially have an app where they say, look, do I download this movie now, or it would be cheaper, or it wouldn't count against my data cap if I did it off-peak. And that would be a policy that the carrier could choose to use. So we're working with the industry, particularly Ericsson and some carriers doing trials to introduce some of these open border APIs. So they're fully open sourced, and it's a way of simply exposing these network layer attributes up the stack. And we think that's helpful. And there's also quite a lot of work going on in just at Google in terms of how TCP interacts with wireless networks. TCP doesn't necessarily behave that well over lossy networks. A packet loss is mistaken for congestion. That often causes TCP to back off much faster than the physical layer actually needs. And so having side information, so there's a project called Quick, which can also use this out-of-band information to allow upper layers of the stack to behave better or more efficiently, given more information about the lower layers. So that's just another example. So just to wrap up, I think our goals here are to share more about what we're doing and to learn, of course, from leaders in the industry. And we're very excited about doing that. I think there are areas around operations and maintenance which are often overlooked. These are really critical in terms of provisioning and scaling a network. and also having processes that are really going to work. So it's not just about the data plane. It's really about the whole life cycle of the services that you're trying to introduce. So I think this is an area where uniformity can be actually extremely helpful across the industry. And the APIs, the open borders example I gave is exactly in this area where you can have additional APIs, additional information that can allow networks to work better. So think of it as no more CapEx, no more OpEx, but you can just use the available capacity more efficiently by maybe shifting the traffic or demand around in ways that are helpful, effectively sort of user level, application level, load balancing, let's say. And overall, I just think we're encouraged to be working more broadly with the community. And so we're very excited. So with that, I'd like to thank everyone. And I am very optimistic that the session today will be very positive. So thank you very much for your time. And I hope today's productive. So thank you very much.
I guess any questions for Craig before we take a short break? Craig, I'm sure you're willing to take.
Yeah, well, sure. Right now, I'll be around during the break. So I'm happy to chat to people then. So any questions? I think people want coffee, Guru. So I think there's coffee through here. The restrooms are through here and turn left.
Okay, maybe we'll take one question and then break. Okay.
Great, sure, please.
Any plan to introduce Android?
Sorry, say that again.
Any thinking about putting your virtualization project or projects you mentioned?
Yes. I think we're happy to discuss sort of our experiences around that. We have to decide sort of which pieces we might open up more of. And so I think we're just at an early stage of exploring that. So I think that's something we'll turn over to the leaders on my team who are part of CORD. And we're definitely happy to explore those opportunities. Great. Another question.
Yeah. Great talk. Question is, you guys are big in Kubernetes, right? So are you planning to bring the technology to OpenCORD?
Which technology, sorry?
Kubernetes, the container technology.
Oh, that's outside my area. So I can't really speak to that. Definitely we'd be happy to make introductions to folks on that team. So, great.
Okay, so thank you, Craig, again. Really appreciate it. I want to take a moment to introduce two key people from Google as well, so that you can have a conversation with them. Ankur, you want to stand up? So Ankur Jain, he is kind of the technical lead, actually in my contact, and then Viru, he is the business side of it. So you should know both of them as well. Okay. So with that, we'll break until 9:30, and hope to see you. We have keynote from AT&T, China Unicom, as well as Linux Foundation. So please come back. Yeah, actually, can you? I don't know what happened. I had a slide on collaborators. They did not.